Okay, how many planes did you guys find in the picture?
To be honest, and say that I don't really understand the plane thing.
Oh, okay. All right. So we have our handy dandy little planes. So, are you okay if I make this one plane T?
Yeah.
Okay, and then I have another plane that is intersecting plane T. Okay. In that plane, intersecting plane T, I have this line AZ and line BN that are lying in my little orange plane and intersecting my blue plane. Okay, so this is what's happening. So my little yellow lines are in my orange plane, intersecting my blue plane. Does this help?
Okay, so the blue line is what separates it, right?
The blue line is where these two intersect. So the blue line is right here. Does this help? No? Do I need to come closer? Two planes. All right, can we name them? It doesn't say to name them, but we can. What's the blue one called? Can we do the easy one? Yeah, okay, we got plane T. Okay, and the one that exists because of the points that are defined, but isn't drawn for us, is, what can we call it? There's lots of options. We can pick any of these points that are in that plane. Those points are all in the same plane. So all we have to do is pick a combination of three of them that don't fall on the same line. So can I call it AXZ, plane AXZ? No, because those are collinear. Can I call it AX, what is that one? N. Can I call it AXN? Yes, because they do not fall on the same line. Okay? Any combination of points that aren't all on the same line. So there's too many for me to list. So I'm just going to pick AXN. Plane AXN. Okay. Name three collinear points. Did you guys do this one? Or did we all get stuck on the first one? Okay. Did you pick them? Which points? A, X, and Z. Good. Can you see another set? B, R, and N. Good. And X, O, and R. Good. Any of those would work. So you can pick these three, those three, or these three. Like an H. Okay, I got a lot of circles. Okay, are points X, O, and R coplanar? Yeah, we said they all lie in which plane? Yeah, which other plane do they also lie in? Yeah, they lie in both of our two planes. Okay, so they lie in, plane T. Did I never write that? I think I just wrote plane. Plane T, they lie in plane T, and they lie in plane AXN because they are actually at the intersection of those two planes. So they are, you know how the intersection of two roads is in both roads, right? So this line, the blue one, is the intersection of our two planes. It's in both planes. All right, what about points? Oh, sorry, at which point do BN and XO, the lines, intersect? So BN, XO. Point R, good. Okay, they got a little bit tricky calling it XO instead of XR, But remember that line, because it has arrows, goes on forever. So even if I don't call it XR, XO, the line is still going through point R because it goes forever. Okay. Cool. Try number 7 really fast. Number 7 is easy compared to the other ones. Really quick, just on your own. Okay, for part A, which line goes through those 2 points? Yep. So how many different ways did we say there were to write it? For this one, it's 4. We don't have a little script letter, so we can either say XY with a line, or we can say line XY. And then we can also flip the orders of the letters so that we'd have 2 more, right? Okay, so there'd be 4 ways to write that one. All right, in 2 different ways, we have to name a plane that contains 3 non-collinear points. So what's the easy way? Plane R. Okay, make sure it's fancy looking, the R. Okay, what's the other way? Yeah, GHF. Does it matter which order I put those letters in? No. Huh? Okay. Which one?
What you're supposed to name the plane by?
Here?
Yeah, right there. Like by letters name the plane. How many points is it? 3?
Oh. Yeah, 3. Okay. Okay. So we have a couple of postulates here that are about points, lines, and planes. A postulate can also be called an axiom. If something is axiomatic, it's like self-evident, okay? It is accepted as true without proof. We'll have a lot of theorems in geometry that we'll have to prove in order to be able to use them. But postulates, those are accepted as true without proof. They are just so basic and fundamental that they can't be proved. They're just seen as self-evident. Okay, it's like, it couldn't be anything else, it has to be this. Okay. Through any 2 points, there is exactly 1 line. Another way that you will hear this stated is that 2 points define a line. Have you heard that yet? What do you think the next one is? If it takes 2 points for a line, what do you think the next one is about? What else have we been talking about? Lines and planes. Okay. How many points to define a plane? 3. What has to be special about those 3 points? Yeah. 2 points can't be non-collinear. Any 2 points fall on a line. It's impossible not to be able to draw a line through 2 points, right? But for 3 points, we need them to be non-collinear to make a plane. So it's going to take 3 points, non-collinear, to define a plane. Okay? If 2 points lie in a blank, then the line containing those points lies in the plane. What do you think? Well, what? Yeah. Plane. Okay, so this one is kind of a little bit like, what? It's not hard, except that it's so duh that it kind of makes you scratch your head a little bit. Take one of your planes, draw 2 dots representing points. Take one of your lines, connect your dots. Is your line in that plane, or is your line punching through the plane and intersecting it in only one spot? In the plane, right? If the 2 points are in the plane, then the line through the points also in the plane, right? Okay. It's just a lot of words. It's not hard. It's just a lot of words. Okay, from algebra, you might remember that a system of equations is a set of 2 or more equations containing 2 or more of the same variables. The coordinates of the solution of the system satisfy all equations in the system. Remember that our answers had to make all of our equations true. Okay, we did where we graphed this line and we graphed this line, and the solution was where the lines crossed. You guys remember doing that in algebra? Okay, we also did it algebraically. We did the substitution method, and we did the elimination method. Do you remember having to add the equations together and canceling out variables, eliminating variables? Okay, that's when we were solving systems. Just like in algebra, an intersection for geometry is the set of all the points that 2 or more figures have in common, that they share. The next 2 postulates describe the intersections involving lines and planes. So, a postulate is accepted as true without what? Proof. It's supposed to be self-evident. Okay, get your lines. If 2 lines intersect, pow, they intersect in exactly how many points? Yeah, exactly 1 point. Okay, we're going to draw a picture. Let's call it point P. All right, get your planes. If 2 planes intersect, they intersect in a what? Are they just touching in 1 point? Or are they touching here and here and here and here and here and here and here? In 1 line, exactly 1 line, good. All right, now we're going to draw a picture of this. And it's going to test our drawing skills, and also it might make our brains explode. Okay, you're just going to do your best. So we're going to try to do this at a little bit of an angle. If I draw my planes intersecting head on, I'm not going to be able to see what's going on. So the trick is to do it at a little bit of an angle. Okay, so you kind of want to draw it from this angle where you can see a little bit of the planes in the back. You understand what I'm saying? So we're going to do like parallelogram. And then another parallelogram. Oh, my brain just died. Okay, so I have to decide which one is going to go in front. Where? I think I picked the pink one and then messed it up. So where the blue plane passes behind the pink plane, I'm going to dash it. Okay, to show that it's back there, but I can't see it through my pink plane. I'm going to do their intersection orange. They're intersecting in this line. Okay, I can see a little bit of the blue through the behind the pink right there. And I should have dashed this pink part. No, that was wrong. I don't know. I messed it up, but I can't figure out what to do. I have to look at a picture. My brain died. I'll try again tomorrow. Okay, any questions about intersecting in a line? Okay. So we're going to draw some more pictures. We're going to sketch a figure that shows two lines intersecting in exactly one point. Okay, well, we just did that one, so that one's easy. Okay, I'm going to call my point M this time. What about a line that lies in a plane? Well, I need a plane. Okay, and then I'm going to just draw my line in the plane. What do you want to call it? A? I hear A? Okay. Okay, so we're going to do a lowercase script K. Okay, so when I'm drawing it to where I can see the whole thing like this, that means it's in the plane. But if I have a line that intersects my plane, and I'm kind of looking at it from the top a little bit, oops, there's going to be part of the line that I can't see because it's behind my paper. You see what I'm saying? I can't see the whole line. So that's the part I'm going to do with a little dashed line. That's how you can tell that something is intersecting and going through a plane. So here's my plane. Okay. I'm going to pick a point where my line is going to intersect. I'm going to pick up here. Up here, I can see my line because it's above the plane. Back here, it's underneath my plane, so I'm going to dash that line. And then when it comes out from behind, it peeks out, I'm going to make it solid again. So it's like I'm Superman and I have X-ray vision and I can see the dashed line to represent the... Is this making sense? Okay. All right, what about two planes? Okay, we're going to do D tomorrow because I kind of messed that one up a little bit. We're going to have another attempt tomorrow after we look at a picture, okay? If I try to do it right now, I'm just going to struggle again, and I'm going to waste your time. So we're going to come back to that one and have a do-over. Redemption. What about a figure that shows two lines intersecting at one point in a plane? Only one of the points, one of the lines lies in the plane. So one is going to punch through, the other one is going to be in the plane. Okay, I'm going to have my plane. Okay, I've got one line in the plane. I'll call this one L. Okay, and they are going to intersect in one point. The other one is intersecting both the line and the plane at that location. I'm going to call him M. Line M. It's not too bad once you get the hang of it. Except for that one. All right, next. Oh, these are kind of fun. Okay, we have a fun symbol for parallel. The symbol for parallel is just two little parallel lines. Oh, that was gross. Like that. Parallel lines are automatically coplanar. Okay? If I'm Okay, I've got my parallel lines here, and I've put them in the same plane, and no matter how I orient my parallel lines in space, do you see that they're still always in the same plane together? Okay. What don't parallel lines ever do? Yeah, they don't ever touch, and the fancy word for that is intersect. They do not intersect. Whenever we have pictures, we're going to be using arrows to show which lines are parallel to each other. So the trick is to be able to count the arrows. So you see that this one has one arrow, that one also has one, but this one down here has two. So what that means is that AB is parallel to EF because they both have one arrow, but it's not parallel to EG because it's got two. Okay, which one is parallel to EG? Yeah, HF. So AB is parallel to EF. Don't forget the line symbol above. And EG is parallel to FH, or HF, if you'd rather. Okay, what does this symbol mean? Yeah, so if I have an intersection and it's marked with a little box like that, it's used to show that an angle measures 90 degrees, which is a right angle. And then we know that the lines are perpendicular. Okay, ran out of room. Okay, so again, AB was parallel to EF, and EG was parallel to FH. Note to self, revise notes so that we don't have to write that twice next year. Okay, perpendicular lines have this little symbol. They are coplanar also, and they intersect at 90-degree angles. In this figure, AB is perpendicular to which line? Parallel to EF, which one is it perpendicular to? Look for the little box. Look for this symbol for AB. Okay, it would be AC if you had this, it would be AC. Do you see how that little box is kind of slanted? That means this one and this one. Does everybody see it? You see it? You got to be careful. It's a little bit sneaky. So AB is going to be perpendicular to AE. All right, what about line EG? This one's easier. GH, line GH. All right, so we did parallel. We did perpendicular. What do you think is next? Skew. So, parallel, perpendicular. Now, if I take my parallel lines and rotate one so that they're not in the same plane anymore, are they ever going to touch? No. Okay, but are they parallel? Now they're skew. So lines that aren't parallel but still never touch, okay, we got a lot of options, are called skew. So parallel and perpendicular lie in the same plane. Skew requires a third dimension. Okay, congratulations, you just made it to 3D. How do you feel? Okay, so skew needs a third dimension. So I did blue for skew. They are not coplanar. Skew lines are not parallel. They do not intersect. Very good. So they're kind of like defined by what they don't do. They don't lie in the same plane. They aren't parallel. They don't intersect. All right, so we're going to look at line AB. This is our target. Okay, there are lots of lines that intersect AB. Which ones are parallel? EF and which other ones? CJ, GH, okay? So can we pick those parallel ones as skew? Okay, can we pick any of the ones like B, J that intersect it? No, so we have to find ones that aren't parallel and aren't intersecting. GH is parallel.
GE, like Jeff.
GE is one. Good. I heard other ones. Who else had one? FH is one. So these ones, any other ones? I can see two more. Which one? See this one? JH?
CG.
CG. Yep. Those four are all skewed to AB. Good. Okay. Skew. Okay. Parallel planes are planes that do not intersect. In the figure, plane ABE is parallel to, let's shade ABE. ABE is this entire plane. So it's kind of like the ceiling of the box. So it's going to be parallel to the floor of the box, right? So which plane kind of defines the floor? Yeah, GCJ, you could use CHJ, you could use GHJ, you could use any combination of these four letters. Okay. Plane What do we say, GCJ? Yes. Yes. Okay, I want to give you 3 minutes to work on this. I'm going to pause it. Yep. Whoops. Well, okay. That's what I meant. All right, 3 lines parallel to line MR. Okay, so our target is MR. That's this one. So even though they didn't draw the arrows, there are lines going along all of these edges, right? So which lines are parallel to line MR? Okay, NS or SN, this one. What else? KP and LQ or QL. Good. Okay, any questions about that? Okay. Next, 2 lines skewed to MR. SP, yes. QP, yes. KL. One more. NK. So you could have picked any 2 of those, and that would have been correct. Okay. All right, next one. Lines perpendicular to MR. RQ and SQ. Oh, sorry. You said it right. RQ and SR. Good. Those are both perpendicular because we have these little boxy symbols. Okay.
LN also work.
Yes, but we don't know why yet.
Oh, okay.
You're right, but we can't prove it yet. But your intuition is good. Yes. Okay. All right. Name a plane parallel to plane MRS. MRS. MRS is this one. Yes, KLP. So this one back here. So you could have called it KLP, KLQ, LQP. Any of those 3 letters would work for that plane back there. Okay. All right. Name 2 planes perpendicular to plane MRS. MRS is still this one. So perpendicular. PQS. Yep, the one on the bottom. And oh, yes, you're right, but we can't really prove that one yet. Yeah, you're right. Okay, questions? Okay, I think you could have also picked this side and this side over here. If you ever are struggling to visualize that, you can just ask me to borrow the tissue box. You know what I mean? And I'll let you write on it and draw all over it. Yes. Yes. Is anyone feeling confident in their answer? No? This might be one of the hardest ones. Okay, let's start by putting those points on the picture. So we want N, K, and R. So here's N, here's K, and there's R. Okay, if you had Okay, which point do you suspect is also in that plane? Yeah. So the easiest way to draw that plane is to connect those points with a straight edge. You can use the side of your ID or one of your planes. Okay? Connect it. And then you're just shading that plane. So imagine that this is a block of cheese and you're just cutting through the cheese to make two wedges like doorstops. It's kind of fun exercise for your brain. All right, what about this one's similar. Name a fourth point in the plane containing points L, K, and S. So I'll do this in red. L, K, and S. What's the other point in that plane? Yeah. R. So don't forget to say point R. But if we made this plane, it would look like this. Kind of fun. All right, we're going to stop there.